Okay, next we're going to talk about proportions. And a proportion is just an equation that tells us that two ratios, which we know are just fractions, are equal. So for example, if I told you that 1/2 equals 5/10, we'd probably all agree with that because you know that 5 is just half of 10. So a proportion is just an equation telling us, that two fractions are equal. So there's 3 different ways that we can tell if a set of ratios are going to form a proportion. One is if they have the same cross products. So what we can do is, for example, here, 6 times 1 is 6, and 3 times 2 is 6. Because these are the same, we're going to say yes, these two fractions would form a proportion because they have the same cross products. The next way, or the next example, 6 times 10 is 60. 5 times 11 is 55. Those are not the same, so they are not a proportion. Okay, on this one, 14 times 2 is 28. 3 times 11 is 33. Those are not the same, so those two fractions would not form a proportion. The next is we can see if they have the same simplest form. So like here, 2 and 4, I can divide both of those by 2 and get 1/2. 40 and 80 are both divisible by 40. That gives me 1/2. Because those are the same, this is yes. So if they have the same simplest form, they are a proportion. Okay, and that applies like here. I could have said, okay, well, 2 and 6 are both divisible by 2. That's 1/3 and 1/3. Those are the same. So it doesn't matter which way you use, they'll work regardless. So on this next one, these are both divisible by 2. That gives me 5/9. 15 and 27 are both divisible by 3. That's 5/9. Because these are the same, that's going to be yes, they form a proportion. And on this last one, 1/4 is already in simplest form. 2 and 10 are both divisible by 2. That's 1/5. 1/4 and 1/5 are not the same simplest form, so that's going to be no. Okay, so you can check to see if they have the same cross products. You can see if they have the same simplest form, or we can look for what's called a common multiplier. What that means is like here, 6 times 5 makes 30, and 7 times 5 is 35. So it's like I just took this first fraction and multiplied the top and the bottom both by 5 to get the second one. So yes, these are a proportion. Okay, but on this next one, I know that 9 times 4 makes 36, and then 8 times 3 makes 24. These are not the same. It does not have a common multiplier, so the answer is no. Okay, and then on this one right here, 9 times 2, I'm kind of going the opposite way, makes 18, and 5 times 2 makes 10, so this would be yes. Okay, this is generally the way that people think is the hardest, and so I like this method if you know it, and you can see the relationship that like this fraction is twice as much as this one. But if you're not sure, then you can always just do cross products. 18 times 5 is 180, or sorry, 90. See, this is why cross products isn't always the best. And then 9 times 10 is 90. Or I could have done simplest form and said 10 and 18 are both divisible by 2. So that's 5/9. This is already in simplest form, and that's 5/9. Okay, now that we know what a proportion is and what makes a proportion true, right, that it's two fractions that are equal to each other, go ahead and turn your paper over and we can use that information to solve proportions. So the first way to solve a proportion is using cross products, right? What we learned on the front side of this paper is that if they're equal, then their cross products are equal, right? Remember back here how 6 equaled 6. Because they were a proportion, they were equal, that means their cross products were the same. So what we can say is that if there's a variable, right, we can do their cross products. 5 times 6 is 30. 15 times c is 15c. So because they're equal, their cross products have to be the same. So 15c equals 30. Then to solve it, we're going to divide both sides by 15 to get c equals 2. So this variable right here would be 2. 5 times 6 is 30, 15 times 2 is 30. So we know we're correct. Okay, on the next one over here on the right, 12 times z is 12z. 48 times 7, I'm gonna have to come do that over here. 48 times 7, 7 times 8 is 56. 7 times 4 is 28. Plus 5 is 33. So this is 336. So 336 equals 12 times z. So now I'm going to divide both sides by 12. 336 divided by 12. 12 goes into 33 2 times. 2 times 12 is 24. Subtract, that's 9. Bring down a 6. 12 goes into 96 8 times. 8 times 12 is 96. So I get 28 equals z. And that's my answer. Okay, another example right here. 12 times 12 is 144. 9 times w is 9w. So 144 equals 9 times w. So I don't want 9w, I want 1w. So I'm going to divide 144 by 9. 9 goes into 14 once. 1 times 9 is 9. Then 9 goes into 54 6 times. 6 times 9 is 54. So I get 16 equals w. Okay, on the next one, we're going to do 63 times 9. 9 times 3 is 27. 6 times 9 is 54. 54 plus 2 is 56. So 567 equals 14 times x. So we have 14x equals 9 times 3, we determined, is that correct? I don't feel like that's right. Let's check it. 9 times 3 is 27. 6 times 9, no, it's right, equals 567. Okay, so now what we're going to do is divide both sides by 14. 567 divided by 14. 14 goes into 56 4 times. 4 times 14 is 56. 0. 14 goes into 0 0 times. So bring down the 7 and then bring down our 0. 14 goes into 70 5 times. So we get x equals 40.5 as my final answer. Okay, I feel like I didn't explain that super well. So 0 times 14 was 0. Okay, then bring down the 7, and then we have to bring down our 0. So 14 goes in there 5 times. Did that make more sense? Okay, next, if sometimes you don't have to use cross products, okay? Sometimes you can look at them and you can see a relationship between the two fractions. For example, 12 times 4, I know that 12 times 4 is 48. So 7 times 4 would be 28. So this x would have to be 28. Because on the front, we talked about how they have to have a common multiplier, or they have a common multiplier if they're a proportion. So it's like I take this whole first fraction and just multiply it by 4 over 4. 12 times 4 is 48. 7 times 4 is 28. Okay, or on this one, I can say, hey, I know that 6 times 3 is 18. So what number could I put in here that times 3 gives me 27? And that would be x equals 9. Okay, so you can use a common multiplier in common sense, or if you're not sure, then you can go ahead and use cross products. So for example, like this example, I would have said, hey, actually this is exactly the one from down here. 12 times 4 is 48, 7 times 4 is 28. Or on this one, 5 times 3 is 15, so I know 2 times 3 is 6. Okay, so if you can see the relationship and you can use a common multiplier in common sense, by all means do it that way. Otherwise, we're going to use cross products, and that'll work every time.